Hello everyone. Let me continue my discussion on undamped free vibrations. Couple of hours back, I had mentioned what is the purpose of study of this undamped free vibrations. Sorry. What we are discussing is not undamped; it is damped free vibrations. Purpose of study of undamped free vibrations. I had told several times it was only to find out the natural frequency of the system to avoid resonance. That was the idea. And now I am discussing damped free vibrations. The purpose of study is not only to get what is the damped natural frequency. It was not only that. The purpose was to know under what circumstances we are going to have vibrations, under what circumstances we are not going to have vibrations. And if at all we have vibrations, because of the damping, the continuous loss of energy and the amplitude of vibrations is going to decrease cycle after cycle. And therefore, after some cycles, you will have amplitude so small that for all practical purpose, you are not having vibrations. Okay? So the first part, under what circumstances we are going to have vibrations, under what circumstances we are not going to have vibrations, that part I discussed in my previous class yesterday. Okay, so we classify the system into three categories: overdamped, that is depending upon the value of zeta. What is zeta? Damping ratio. What is damping ratio? The ratio of the actual damping coefficient to the imaginary damping coefficient, which we call it as a critical damping coefficient. Cc equal to 2m into omega m. You find out what is C by Cc, then find out what is the zeta of the system. If zeta is more than 1, then you will not have vibrations. If zeta is equal to 1, then also will not have vibrations. The system, if zeta is equal to 1, it is called as a critically damped system. In case of critically damped system and overdamped system, you will not have free vibrations, and hence this is the circumstances under which we are not going to have vibrations. Then we discuss the case separately. Zeta is less than 1. The case what is known as underdamped system. Okay, and wonderfully, and when we expressed, we analyzed, we ended up with a result, say x of t, the displacement which is given by this kind of expression. Because of the presence of cosine term or sine term, anyway, so cosine I can replace by sine, so both of them are sine, and I can express it something like this. Or instead of replacing, having both sine, I can have both cosine, and I can write the same expression either in this manner or in this manner very easily without any difficulty. Any of this, all of this. So because of the presence of this term or these two terms, and it is possible that x of t will change its sign from plus to plus, again plus minus, this is possible, and therefore that will tell us that underdamped system shall have vibrations, can have free vibrations, and that is the expression. Okay, these are the expressions. Now I want to tell further thing, that part. What was that? So if at all I have vibrations, I know that the amplitude of vibrations is going to continuously decrease. Okay, so how is that, and at what rate for a given system, all that, and the study is what is called as a logarithmic decrement. So I am going to have a log term, natural log, and that's why it is called as a logarithmic decrement. Decrement is nothing but decrease. So before I really think of that, so I have a small thing, so I am slightly varying, and please come back here. So x of t equal to x sine of omega t plus 0. 0 is nothing but the phase difference. The phase difference in general x sine of omega t plus phi. That's how we write down. So what is this? This is an expression for simple harmonic motion. So we know that simple harmonic motion is nothing but gives us vibrations. Okay, that's what we have studied already. And x of t. So this I want to plot it. Okay, x, this capital X is what? Capital X is nothing but the amplitude. And what is omega? Omega is a frequency in radians per second. Okay, so I know this x, I know omega, and I want to plot it. Okay, I want to plot it for different time, for a longer time, but I am showing here for one cycle, okay. So I shall start with it. Say if t is equal to small t is equal to pi divided by 2 omega. If t is equal to pi divided by 2 omega, substitute what happens? Omega into pi divided by 2 omega. Omega cancels. You have pi by 2. Sin pi by 2 is what? It is 1. So that time you have x. So I have marked this value x. So similarly, if small t is pi divided by omega. So omega cancels and you have sin pi is sin 180 degrees, that is 0. This is the case. Similarly, if t is equal to 3 pi divided by 2 omega, 3 pi divided by 2 omega, omega cancels, you have 3 pi by 2 is 270 degrees. So sin 270 degrees is minus 1. So therefore minus 1 into x, that is nothing but this. So similarly, if you have 4 pi by 2 omega, okay, so substitute that, omega cancels, you have 4 pi by 2, 4 pi by 2 is 2 pi is 360 degrees, sin 360 degrees is 0, that's what. So if I plot this is how it is going to be. You have like this. So this is a typical sine curve. I am drawing it for only one cycle. Again, please remember, this is what is going to repeat. Okay, so this is being repeated after this much time. That is what I call it as, say this is what, from here to here, the duration of the time is called as the time period. So how much is the time period? This is 0, and therefore 4 pi divided by 2 omega, 2 and 2 cancels, so what is that? 2 pi by omega. So one time period is always equal to 2 pi divided by omega, 2 pi divided by frequency. The same thing can also be obtained in a different way. So f is equal to 1 by t, you know, the t is the time period, f divided by 180. And you also know that omega is equal to 2 pi f. So 2 pi into f is what? 1 by t, 2 pi. So omega is equal to 2 pi by t. I want to take t this side. T is equal to 2 pi by omega. The time period of a cycle is equal to 2 pi divided by omega. Okay, please remember here, this is what is called as the amplitude, and this is what is called as the frequency. This is what is called as the phase difference. So by chance, for this, if instead of 0, if I have 45 degrees, the phase difference, what happens? This cycle, instead of starting here, it will start after 45 degrees and then it is going to repeat, nothing else. This phi will only make this cycle to shift. Okay, so either this side or this side, depending upon whether you have plus 5 or minus 5. Okay, I have taken 0 degrees, therefore there is no phase difference in this case. So I hope you have understood. T is equal to 2 pi by omega. So what is the time period of this? So therefore first thing, find out what is the frequency. Frequency is always the coefficient of the t term, coefficient of t within this sine or cosine. And what is this x? X is the amplitude. Very important. Okay, this term shall indicate what is the amplitude, and this term shall indicate what is the frequency. So therefore, let me come back here. So here also I shall choose one of them. One of these three I shall indicate. All of them remain same. So I shall choose this. X is equal to c into e raised to minus zeta into omega n into t into sine of, what is that? Omega dn into t plus phi. Phi is the phase difference. And what is the frequency? Frequency is omega dn. And omega dn, we know that. What is omega dn? This is nothing but root of 1 minus zeta square into omega n. Don't forget that. So while deriving this, we have replaced this term by omega dn. Omega dn is root of 1 minus zeta square multiplied by omega n. What is omega n? Root of k by n. All that we know. Okay? So let me come back here. So compare this term with this. So here, okay, what is the amplitude? The amplitude is not only see, this entire thing is what is amplitude. So this thing is amplitude. And what is frequency? Frequency is omega dn. Omega dn is frequency. Let me write down here. Omega dn is frequency, and so C into e raised to minus zeta into omega n into t is what? Is amplitude. So in the simple harmonic motion here and here, okay, here the amplitude is x, which is not a function of time. So the amplitude remains same. Therefore, this is x, this is x, this is x, this is x, this is x. The amplitude will remain same. But here the amplitude c into e raised to minus zeta into omega n into t. You have t here. The amplitude is also a function of time. The amplitude is also a function of time. In fact, this e raised to minus zeta into omega n into t, okay, this term is going to become smaller and smaller as t increases. So, for example, e raised to minus 10, then e raised to minus 20, e raised to minus 30, like that. This is smaller than this. This is smaller than this. Okay, as the t increases, this minus, this is constant, zeta into omega n. Okay, and that into t, that means it is going to become something like this, and therefore its value is going to decrease. C is a constant. So the amplitude is c into e raised to minus zeta into omega n into t. So what is the amplitude? Amplitude of vibration is equal to c into e into minus zeta into omega n into t. This is general expression. The amplitude is not going to anywhere. Say you don't have amplitude at any value of t. So please remember, only if t is equal to pi by 2 omega, you have amplitude. You have amplitude. You have amplitude. You have amplitude. You have amplitude like that. Okay. Let at t equal to tn. Let at t equal to tn, I have amplitude. Let amplitude, let me call this as x suffix n. The amplitude after n cycles, xn, that is at t equal to tn. Okay, that is nothing but c into e raised to minus zeta into omega n. Okay. I have made a mistake. Is it omega dn? No? Okay, so this is sine of. Okay, this is right. Minus zeta omega n. Right. Minus zeta into omega n into t. T is what? T is tn. T is tn. So this is the amplitude. Then again, let at t equal to tn plus t. After one time period, what is one time period? One time period, that is nothing but tn is tn plus what is one time period? It is always equal to 2 pi divided by the frequency. What is frequency? Frequency is omega dn. So that means at t equal to this much, that is nothing but I have completed one more cycle. So what is the amplitude? Amplitude now. In the same notation, what should I call this? X. Okay, this is after n cycle. So now one more cycle has happened. So probably I can call this as x n plus 1. So this is equal to, what is that? C as it is into e raised to minus zeta into omega n into, what is t now? What is the time? That is nothing but this t. I am substituting. What is t? T is equal to tn plus 2 pi divided by omega dn. Okay, so now let me take the ratio of the two amplitudes. What is that? So So xn, I want to divide it. Xn divided by xn plus 1. I want to divide the ratio of the two consecutive amplitudes. Xn divided by xn plus 1. Let me substitute here. What is xn? Xn, I have to put it here. It is c into e raised to minus zeta into omega n into Tn divided by xn plus 1, that is c into e raised to minus zeta into omega n into bracket Tn plus 2 pi divided by omega dn. I hope it's clear. Okay, so probably I can cancel this c and c. So I don't need it now. You have understood the concept what I wanted to explain, and therefore so I make use of this space now. Okay, what is that? What is the left hand side? The left hand side is xn divided by xn plus 1. What is this ratio? The ratio of two consecutive amplitudes. N can be 1, in that case this is 2, x1 upon x2. If n is 2, x2 upon x3. If n is 5, x5 upon x6, like that. Okay, this is equal to, so now e raised to, both of them e raised to only. So I shall take the denominator to the numerator. So that becomes e raised to zeta into omega n into Tn. Becomes plus. When I take it to the numerator, e raised to 1 upon e raised to minus x is equal to, is as well as e raised to x. The same thing I am writing in the first term. E raised to this minus becomes plus. E raised to zeta into omega n into Tn plus 2 pi divided by omega dn. This is one term. And the numerator is already there, that also e raised to minus zeta into omega n into Tn. Okay, so now I shall simplify this. E raised to, this I can take it inside. So e raised to, so if I, this thing, zeta into omega n, I just shall take it outside. Into bracket. It is as good as e raised to m into e raised to n. What is that? E raised to m plus n. I would like to club it. E raised to zeta omega n, I would like to take outside. So what is remaining? It is Tn plus 2 pi divided by omega dn. Okay, so this is minus zeta omega n has been taken outside. What is remaining? It is Tn. So this Tn and this Tn cancels. So this is nothing but e raised to zeta omega n into 2 pi. So I can write it, maybe in the next step I shall write it in the beginning. 2 pi divided by omega dn. What is omega dn? Omega dn is root of 1 minus zeta square multiplied by omega n. I have written there. So this omega n and this omega n cancels. So therefore I have got it now. E raised to, what is that? 2 pi zeta divided by root of 1 minus zeta square. Okay, so now very interesting. Please see here, 2 pi is a constant. Anyway, zeta, what is zeta? The damping ratio for a given system, K, M, C, they are all constants. Then Cc is constant, C is also constant, zeta is also constant for a given system. For a given system, this zeta is constant, and therefore this whole thing is constant, and therefore this I write it as E raised to delta. And what is delta? Delta I am going to call it as logarithmic decrement. Why? Okay. So now what is the left hand side? It is xn divided by xn plus 1. I would like to take natural log of xn divided by xn plus 1. Okay, natural log. I hope you understand. Log to base e. So this is equal to delta into log e. Log e to base e is 1. Therefore, this is what is called as the expression, or what is called as logarithmic decrement. Delta is called as logarithmic decrement. Okay, so can you define logarithmic decrement? Logarithmic decrement delta. Can you define it? Okay, so if you start with, what is that? It is a natural log of logarithmic decrement delta is the natural log of the ratio of the two consecutive amplitudes. If you start this ratio in the beginning only, then you are stuck. It is natural log of the ratio of the two consecutive amplitudes is known as logarithmic decrement, and logarithmic decrement is a constant. It is a constant. How much is that? This is equal to 2 pi zeta divided by root of 1 minus zeta square. So many times the various versions of this is going to be asked. Prove that delta is equal to 2 pi zeta divided by root of 1 minus zeta square. Then obtain the expression for logarithmic decrement. Okay, the various ways that has been asked. Okay, so now I have got what is called as delta. Delta is what? It is equal to natural log of xn divided by xn plus 1. Okay, do you agree that if this delta is natural log of x1 divided by x2? Okay, so the same thing, delta is also equal to natural log of x2 divided by x3. The same delta is also equal to natural log of x3 divided by x4. And so on. This is also equal to delta, which is equal to natural log of xn minus 1 divided by xn. All of them are true, no? Okay. Now, I just want to multiply x1 upon x2, multiplied by x2 upon x3, multiplied by x3 upon x4, and so on. xn minus 1 divided by xn. So if I simplify, what do I get? x2 cancels, x3 cancels, x4 cancels, xn minus 1 cancels. What you are going to get? This is x1 divided by xn. Okay, I would like to take natural log both sides. Natural log both sides. What is that? If I take log, okay, log of a into b is what? Log a plus log b. If I take log on either side, I have what is called as ln of x1 by x2 plus ln of x2 by x3 plus ln of x3 by x4 and so on, plus natural log of xn minus 1 divided by xn. How many such terms are there? This is 1, 2, 3, 4 like that. I have n terms. So this is equal to what is that? Natural log of x1 divided by xn. Okay, so what is left hand side? Do I give that this is delta? Then what is this? This also is delta. Then what is this? This also is delta. And so on. And this also is delta. This is equal to natural log of x1 divided by xn. Therefore, I shall write the reverse. Natural log of x1 divided by xn is equal to what? This is n times delta. Or the same thing can also be written as delta. Delta is equal to 1 upon n, take that n to the other side, into natural log of x1 divided by xn. So this is what we call it as expression for logarithmic decrement in different versions, different forms. Any of them may be asked in the examination. Okay, very important. And using this many times, you normally have a question for about 10 marks. And studying, it is substitution like. Maybe one such problem we can see it now. Okay, so you also have a problem. You have been sent the problem. We shall read it together and solve that problem. We shall read the problem whatever you also have, and we will continue to read it. This is a question which has appeared in December 2010 examination, and this is for 10 marks. Okay, so the question goes like this. A machine weighing 7.6 kg is mounted on springs and is fitted with a dashboard to damp out vibrations. There are three parallel springs. Each of stiffness 1 Newton per millimeter. And it is found that the amplitude of vibration decreases from 38.4 millimeter to 6.4 millimeter in 2 complete oscillations. Assume that the damping force varies proportionately with velocity. That means it is the damping provided is viscous damping. Only in viscous damping the resistance force is directly proportional to the velocity. Okay, so determine the resistance of the dashpot at unit velocity. The ratio of frequency of damped vibration to frequency of undamped vibration. The periodic time of the damped vibration. Okay, if it is not clear, okay, I wish you to read it another couple of times if required. Okay, we shall make a figure. So what is that? We have a machine whose mass is 7.6 kg. So I have what is called as M, which is equal to 7.6 kg. This has been suspended on 3 springs, 3 parallel springs. Okay, let me call them as K1, K1, and this also is K1. You know what is the stiffness of that. Then you also have what is called as one dashpot. And this is how this is the ground, and there are 3 springs and this thing. Okay, normally we have the inverted diagram, nothing else. It is both of them are one and the same. Normally we have something like this. We have one spring and one mass here, and this is how the mass is. Okay, both of them are one and the same. The first thing, I don't want to have 3 springs. I shall have only one spring. And let me call it as K. K is the equivalent to this thing. What is that? So parallel, 1, 2, 3, both of them, all 3 are parallel. In case of parallel, the stiffness is equal to the sum of the 3. Okay, this is K is equal to 3 times K1. 3 times K1. Then you have a dashpot. And this stiffness, whose coefficient of damping is C, which we don't know, we shall find it out. So this is the answer. So now I shall write down what is the data. What is the data given in the problem of all things. Okay, 7.6 kg, that is M. M is 7.6 kg. Okay, 7.6 kg dashpot. There are 3 parallel springs. Therefore, K is equal to K. K is 3K1. That is equal to, this is the sum of 3 Newton per millimeter. Am I right? It is 1 Newton per millimeter. So I don't want millimeter. Therefore, this I shall call it as 3. Millimeter is nothing but 3 to 10 raised to 3 Newton per meter. So 1 millimeter is 10 raised to minus 3. That goes up 3 into 10 raised to 3. K is known. Okay. Then what else you know? it is found that the amplitude of vibration diminishes from, okay, at some time, say xl is 38.4 millimeter. The amplitude is 38.4 millimeter. Then after two cycles, what is that? xn plus 2. It becomes 6.4 millimeter. It becomes 6.4 millimeter. Okay. So now we shall make use of all this and then. Okay. So just now we obtained natural log of x1 divided by xn is equal to n into delta. This is what we got. So here we have only two cycles. Natural log of, okay, two cycles. What is that? xn divided by xn plus 2. We have two cycles. So this is equal to 2 times delta. So this is equal to natural log of, what is xn? Xn is 38.4. What is xn plus 2? 6.4. Please remember ln, it is natural log to base e. This is equal to 2 into delta. So from this you can easily find out delta. So delta doesn't have any dimensions. 2 pi zeta. Delta is what? Okay, you will find out this value. Please remember, this value is known to you. What is this? This is equal to 2 pi zeta divided by root of 1 minus zeta square. You know this value. Please remember, from this you find out this value. This value is equal to this. From this, what do you find out? It will take few minutes. Okay? Zeta is equal to square this term and square this term also. 4 pi square zeta square divided by 1 minus zeta square. That is how you can find out. So you can easily find out what is zeta. Okay? So once you know find out zeta, then what is next? You can easily find out what is omega n. Omega n is what? Square root of k divided by m. You can find out this omega n. Okay, so omega n is known to you. Then you can find out what is Cc. So what is Cc? Cc is equal to 2m into omega n. So this is known to you. You know omega n from this. M is known to you. Therefore Cc is known to you. M is 7.6 kg. Omega n is this value. Okay, you know Cc. So what is zeta? Zeta is equal to C divided by Cc. So you know zeta, you know Cc, and from this you find out C. C is equal to, what is the unit of C? C is Newton, the force per unit velocity, meter per second. That second will go up. So C value is known to you. So C, okay, what is asked? So the resistance of the dashpot at unit velocity, if the velocity is 1, you know that F is equal to C into x dot. If x dot is 1, what is that? F is equal to C. What you are asked to find out is C. Okay, the answer for the first one is the resistance force of the dashpot at unit velocity. That is nothing but C, which we have found out. Number 2, the ratio of frequency of damped vibration to the frequency of undamped vibration. Okay, so you are asked to find out what is the ratio of omega dn. This is the ratio of damped vibrations and the undamped vibrations. Let me read it again. The ratio of frequency of damped vibration to the frequency of undamped vibration. This is what? What is omega dn? This is nothing but omega n into root of 1 minus zeta square. And this is nothing but omega n. Yes, omega n cancels. You know zeta, you have already found. Substitute and simplify. This is known. Next, number 3. Periodic time of damped vibrations. So you are asked to find out what is the T of damped. This is nothing but 2 pi divided by omega dn. And what is omega dn? Omega dn is nothing but root of 1 minus zeta square multiplied by omega n. You know zeta, you know this. you know omega, this. So the whole thing is no, that's our omega d. Substitute that omega d in here. So this is how we find out what. So in seconds. So all the things are done. So this carries 10 marks. This is the kind of question what you are going to face, and just compare this kind of question with the undamped free vibrations where you require a lot of thinking. So therefore this question is highly reliable, and maybe I shall spend another couple of hours on the various problems which have appeared in the question paper. Thank you. All the best.